So on these pink notes, we are subtracting rational expressions. Rational just means function. And you will do better if you change subtraction to adding the opposite. Many times when we try to subtract, we make a sign mistake, like I did on problem number 1. Did I make a sign mistake on problem number 1? Is that the right answer? It's not the right answer, because this is the same as adding a -7, and then I would realize that that was supposed to be a -1 instead of a +1. You will do better if you change subtraction to adding a negative. That is the same mathematically. Subtracting is the same thing as adding a negative, of course using your integer rules. Then you combine like terms. Just like adding, you find a common denominator, and the answer also has that common denominator. On adding and subtracting both, you have to find a common denominator. And the answer has the same common denominator. This is the next problem number 1. I don't know who, I didn't number these. And so on this next problem, I guarantee you're going to do better if you change subtraction to adding a negative. Now it's an adding problem, just like we were doing yesterday. For adding problems, we need to find a common denominator. X plus 2, x minus 2 is going to be the common denominator. It doesn't have anything that overlaps. This is where the red pen will help you out. What am I going to multiply this denominator by so it's going to equal the common denominator? What am I going to multiply this denominator so it will equal the common denominator? And this is just to divide my problem so all my steps don't run together. Let's see what color. Multiply 3 times 2. The 2 is negative, so that'll be a -6. That will be 3x. That will be -8x. That will be -16, and it's all over my common denominator. Then you combine like terms. So, this term and this term are alike, so that will be -5x minus 22. That's a perfectly good answer, but sometimes you will see that where the negative is factored out. You do not have to do that, but you can if you want to. Yes. Okay, this is a -22 because that was a -6 and a -16, and I'm combining like terms. How did this get to be a -16? -8 times 2. You need to change the sign in the very first step so you don't make a sign mistake somewhere down in the problem. So with my red pen, the very first step, I'm going to change subtracting to adding a negative. you will be much less likely to make a sign mistake if you go ahead and do that in the very first step. That's just to divide my problem into several steps. My common denominator is x plus 1, x minus 1. Just helps it show up a little bit better if you use your red pen. What am I going to multiply this by? So it's going to equal that denominator. What am I going to multiply this denominator so it equals that denominator? Then it's going to have the same common denominator, so I distribute negative 3 plus 3x. If I multiply that together, I get negative x squared. If I multiply that, I get negative x or negative 1x. And I need to combine like terms. That doesn't have any like terms. And we usually write the x squared first. Now we need to see if we can factor that to see if anything will cancel. I have great difficulty trying to factor if we start with a negative sign, so I'm going to factor out a negative sign. So I need to see if that will factor. So I multiply the first term times the last term, and I get a 3. Positive 3. The factors of 3 are 1 and 3. If I put the signs in like that, it does add up to be a negative 2. However, does that multiply to get a positive 3? So if I put the signs like that, it multiplies for a positive 3, but now it doesn't add up to a negative 2 anymore. If I put the signs like that, it multiplies to a positive 3, but it still doesn't add to a negative 2. And so this does not factor anymore. It doesn't cancel anymore. That is the answer. The first thing I need to do is change the addition sign, the subtraction to an addition sign, and that changes the sign not just on the x, but on the 7. I am subtracting an x and a negative 7. Subtracting x and subtracting a negative 7 is the same thing as adding a 7. Let's make sure that you understand that. What I need to do is change the subtraction to an addition, and that will change the signs on both of these, because both of those are behind the subtraction sign. Both of those are getting subtracted. Then, as you can see, already, in a few minutes we're going to lunch. As you can see, I already factored out the denominator. That factored and that factored. Okay, what are we going to use for my common denominator? We start with the first denominator. Now, what do we need from the second denominator? We need a 4, but we already have a 2. Isn't 2 times 2 4? So since we already have a 2, we just need to multiply by another 2, because 2 times 2 is 4. Is this equal to the second denominator? Yes. And is this much equal to the first denominator. So that is going to be our least common denominator. If we put a 4 here, we will have a common denominator. It just won't be the least common denominator, and so there's going to be more canceling at the end. I'd rather cancel it out at the beginning than the end. Okay, what is this denominator going to need? It already has a 2. It just needs another 2. 2 times 2 is 4. What does this denominator need? Nothing. So what was the question over here? That is 4. 2 times 2 is 4. If, because that's where the red pen comes in. What did I need? If I already had the 2 there, what did I need to multiply by to get a 4? Just a 2. If you multiply this by a 4, then you would have to have a 4 down here in the denominator. That's okay. You can do it that way, but there's going to be more canceling at the end. Combine like terms. What do we get when we combine like terms? And what happens with my x minus 3's? This one cancels this one. This 4 is in the denominator, so your answer 4 is in the denominator. Some people let those crawl out of the denominator. The 4 is in the denominator. Over here, you do know where I got 4. 2 times 2 is 4. And so the 4 is in the denominator over here. This is your common, I didn't do the first thing first. The first thing is to change that to a minus x and a minus 4. Then you find your common denominator. The numerator will factor, but I'm not going to factor it right now, and I'll show you why in a minute. Okay, so just leave this numerator right here. You can factor out a 2, but don't do that yet. Then put it back if you already did that yet. Okay, so what am I going to need? This denominator, I don't need to multiply anything by that denominator. What am I going to need to multiply here? So this is going to be x plus 2, x minus 2 is my denominator. This is going to be 2x squared minus 16. Okay, what do I do with this? You either have to FOIL it or use a box problem. You have to multiply it out with either FOIL or a box problem, and then you would get if you multiplied it out with either a box problem or FOIL, that's what you would get. I haven't combined my like terms yet, so I'm going to combine this term and this term. So what do you get when you combine like terms? This one and this one make x squared. This makes negative 2x. This makes negative 8. The factors of negative 8, is there a way to put in my signs to come up with a negative 2? Does that multiply to get a negative 8? Yes, and so this would factor into x plus 2, x minus 4. This would factor into x plus, oh, it's already factored, I should say. Then what's going to happen to the x plus 2? That's going to cancel with that term. X minus 4 over x minus 2 is going to be your final answer. Now, does everybody have that copied down? Raise your hand if you need a minute more to get that copied down. So, what if way back here in this first step, you factored out a 2. I did that on one of my homework problems. If you factored out a 2, does anything cancel? Can x squared minus 8 factor some more? Is 8 a perfect square number? No. When you cancel, that's it, what I'm going through. If you factor out the 2 and something cancels, that's a good idea. If you factor out the 2 and the x squared minus 8 will factor out some more, then you factor it out some more. But x squared minus 8 is not a perfect square. 8's not a perfect square. 9 is. And so, does anything cancel by that factoring? The answer to that is no. So don't do it, because down here in this step down here, you're going to have to multiply the things back together. So you're just making more work for yourself if once you factor, it does